Hello.
Daniel, I can see you. Can you hear me?
Yep. Hello.
All right. Okay, so Jamboard. And Daniel. Jamboard. Oh, this will be physics again.
You have the thing, you have the questions that I sent to you. Which Jamboard are you in?
In the physics one, is that good?
Physics one. Can we start a new one?
Oh, that's up to you. No problem.
Yeah, I'll start a new one then, because there isn't
All
much
right.
space left.
Ah, right. Okay, sure.
Okay, added you.
Okay. Right. So you can tell me which question to talk about. You can share your screen if you want.
Can you open the PDF on your side? Then I open the PDF on my side, so we don't need to paste the questions into the Jamboard.
No problem.
Let me know when you're ready to start.
Oh, I'm ready. I'm ready. That's why I'm asking you which question.
Oh, I think question 2 first.
All right. Sorry, the problem is open. I've read the question, so you can tell me what your question is.
Sorry, you're a bit unclear. Like, I can't really hear you.
Not very. Can you hear me? Is it better?
Yeah, I can hear you, but it sounds like you're very muffled.
So, okay, is that better? Is that better? Not really.
Not really. Yeah. It's okay. I'll just listen harder.
After 2 minutes, if this is not getting better, I'll switch. I'll change to something. All right. Okay. All right. So question 2, your question will be.
Which statement about the atomic spectra is not true? Okay, wait, no, I understand too. But that's just D, I think.
Okay, wait. Yeah. Yeah, D is definitely wrong. Okay. Yeah. If you know that the rest is why the rest is correct, then good knowledge. Right. Any question?
No. How about question 3?
All right. Okay. It's all right. What is your question?
What's the answer?
Beta decay would be?
What?
Beta decay would be?
What are you asking for?
No, as in beta decay is? As in what is a beta decay?
Are you asking for the formula?
No. As in beta decay is something very simple. All right. So beta decay is ejection of electron. Finish. So far so good. I'm ejecting an electron now. Okay. Is this okay or not? All right. Okay. So electron is, they call it 0 minus 1. That's one way to call it. But you already know what's electron, so there is no mystery here. So beta is electron, there is no mystery. Now, if I emit an electron, will my charge change?
Yes.
So D must be wrong, right? So D will change, right? That makes sense, right? Will my proton number change?
No.
Now, this is the very interesting thing. I will explain so that you're very clear, right? In chemistry, when you eject electron, you eject your own electron. Obviously, every atom has neutron, proton, and electron. So far, so good. So if you eject your electron, your proton shouldn't be disturbed. Your proton and neutron is in the center, and your electron is orbiting that center. No changes to the center should be happening. That should be what we're thinking about. That's chemistry. In physics, they specifically investigate what happens when an electron is emitted from the center, which you would notice has no electron originally. The electron is out there. Is this okay first or not?
Are you drawing somewhere?
I am not drawing. I was saying things.
Okay.
Right. I will be drawing again then. Right in page 1. Chemistry. Okay. That's what happened in chemistry and sometimes in physics also. The electron got ejected. Okay?
Okay.
In our particular physics right now, we are concerned with the middle guy, which has protons and neutrons, right? Something like that. And this center emits electron, ejects electron. Let's be clear about that first. That is your beta decay. The word decay always means that it ejects from the center, the nucleons. the nucleus. It always means it never meant the electron outside kena eject. Clear first or not?
Yeah.
Now, you notice that the center has no electron whatsoever, but it is still ejecting electron. This is not a bluff. That happens, right? When this eject electron, put it simple, a neutron, here's a neutron becomes proton. That's how it is able to eject an electron. If this hopefully makes some sense.
Mm-hmm.
Then you should know the answer already.
A?
Yep. Would that be okay?
I guess, yeah.
Mm-hmm.
So, although the proton and neutron numbers are changing, overall the nuclear number stays the same.
That makes sense, because one neutron changes to one proton. It's still 1-1.
Okay. Wait, I'm writing it now.
Oh, please.
Okay.
Which one is your next question?
5, I guess. 5 seems pretty simple, but I just want to make sure I got it right.
Oh, okay. All right. Let me see for
What is a counter rate?
Oh, interesting. Have you seen a Geiger counter before? A measurement for radiation. Have you seen it before?
A Geiger?
Yeah, it's called a Geiger counter. Probably they will have just show you that.
Okay.
This one probably. Yeah. All right. Okay. So I'll share my screen very briefly. Share my screen. Okay. Can you see my screen? It's a video. Oh, I should share my sound. So if not, we cannot hear it. The Geiger counter is beeps, I guess. Yes. Okay. Can you see my screen?
On Zoom.
Yeah, on Zoom.
Yeah.
On Zoom.
Okay.
All right. So
it's overloaded. Radiation is frightening.
So that sound just now has a certain beep to it, right? And play that. Beep, 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 beep. Right. Okay, never mind the guy saying things. So the beep, beep, beep is basically, let's just put it that he's counting radiation. That means something entered the meter. The moment something radioactive entered the meter, he's able to detect it, and then he will register that as a beep. So 2
So
beeps
the
means,
higher the count rate, the more radioactive.
yeah, because the more radiation is entering the meter and presumably your body. Right? It's quite simple, right? More count, more radiation happening. All right. One thing to notice so that the background rate is clear. He is not counting something radioactive per se in this picture. He's going to a radioactive place. That most radioactive place in this case is probably Chernobyl. Probably, I'm guessing. I haven't seen this video before. My point is, you don't have to point to something radioactive to register the count. That's not a fluke. It is true that radioactivity is happening all around us. The count rate is a bit slow, but the count rate is there. That is what they mean by background radioactive count. It's there everywhere. It's not because of a particular thing. I'm putting it very simplified. Would that be okay so far?
Okay.
Right. So now stopping the share. So that is the count rate look. So he's saying that he's measuring the detector, the Geiger detector is measuring something radioactive, the radioactive nuclide. But he will always measure the background count rate at the same time. You cannot separate them both. When you aim at something, you're aiming at that guy and also at the background because the background is always with us. That's the meaning of the question. What is the average background count rate? He's asking you, basically. Will that be okay so far? Okay, yeah?
Okay.
Right. So that's the meaning of the question. Do you know how to start?
Would it be the area under the graph by any chance?
I don't think so. Right. I don't think so.
Okay.
I'm not sure what the area under the graph means. It might mean something, to be fair. It might mean something, but I'm not sure what it means. I'm not sure what it means right now. Furthermore, area under the graph usually means you're integrating. But this one, it's background count rate. So the count rate is already there. So I feel that we shouldn't be integrating because if we integrate count rate, it will be something else other than count rate. I'm not sure what that is, but it's not going to be a count rate, so to speak. So since the question asks for count rate, I feel that we should stay in this graph, so to speak. Oh, okay. I understand what you're saying. Okay, so please notice that the graph is misleading for some reason. I'm not really sure why he's doing that. This is not 0, this is 8. I'm very uncomfortable with the way he presents the graph. But there you go, that's an 8. Would that be okay? Are you okay, Daniel? I'm looking at I'm writing something at the chat board. Right? Yeah, second page. So that's an 8. That's not a 0, right? I think that makes the graph more sensible to me. Right. I'll tell you my first step. My first step, when he tells me half-life, that means I don't really care about the average background count rate. I just look at, half-life. Half-life, very easy one, right? He's telling me that at 20 seconds, the radioactive nuclide basically halves its strength. Simple thing, right? 20 seconds, half its strength. That means it's not a very strong radioactive nuclide. It will go, if you enlarge it, everything becomes wrong, right? Okay, so don't enlarge it yet. All right.
That's an
accident. You just do stuff. No problem. Just do your stuff. Right? Okay.
So at 20 seconds, half-life,
you will have half his strength. So this already tells me so many things. First of all, First of all, the halving happens from 9 to 11. Correct or not? The halving happens from 9 to 11. You would notice that 9 to 11 is not half lah. Half of 19 is 9.5. And this is already telling me a lot already. This is -8, right? So this tells me that the original nuclide, what we are aiming for, has a strength of 16, no? Simple.
Oh, because half of it is fun.
8, ma?
Okay.
Half of it is 8, ma? So 16, ma? So his original strength is 16. Our average background counted 3, lo? Finish, lo?
Or is it 3?
That is the accident. That is almost like a byproduct of my understanding about half-life. Half-life is very simple, just like that one. If at 20 seconds you're halving, and your halving means you minus 8.
Is the background radiation.
Yeah, background radiation. What else?
Okay.
What else is it? Yeah, it's a background radiation. Yeah, radiation happening around
19
us.
minus 16 equals 3.
Yeah, which makes the graph totally making sense, lah. If this is okay with you, lah. I hope this makes sense. This is not supposed to be mysterious or difficult. This is supposed to be,
Yes,
oh, like
okay.
that one. Okay. Right.
Yes.
Right. Okay. Right. Next question, please.
6.
What's your question? I mean, this is not the easiest thing, but it's also not the most difficult thing. Like, what's your question?
How to do?
Do you understand the question first?
No.
If you don't understand the question, ask something about the question first. Not how to do. No. What is it that you don't understand about the question?
What is asking for?
Okay, so the basic principle here that mass can go for energy, energy can go for mass, but they must be conserved together. The mass plus energy must be conserved. I can create mass from energy, I can create energy from mass, but I cannot create mass out of nothing, and I cannot create energy out of nothing. Basically, we're just saying that mass and energy are interchangeable and they are conserved. They shouldn't disappear. They also shouldn't appear out of nowhere. That is the basic principle here. Will that be okay first?
Mm-hmm.
Right. Now, read the question. Helium nuclei, there you go, on the right-hand side, right, may result from the bombardment, whatever that is, that's lithium plus proton. He's already telling us in the reaction, right? Now, oh dear, it's going to make a lot of assumption. Right. So the word bombardment means that the proton is moving very fast, right? I bombard the lithium with proton. I mean, correct or not? Does that make some sense?
Yeah.
If that's right. And I'm shooting, basically I'm shooting the lithium with a proton. Now, here is what I'm going to assume. I'm going to assume something that does not make sense immediately. I'm going to assume that the lithium is not moving. That's quite okay. The target is not moving. But the bullet, the proton, I'm shooting it with the bullet of proton. The proton is also not moving at all. I am assuming that. That totally does not make sense. I will concede that first. Okay, even though I just said that I'm going to shoot a nuclei with a proton. Okay, lithium not moving, proton not moving. This has the effect of simplifying my situation, which totally does not make sense. Let me repeat this. This does not make sense. But it's simplifying my situation in that lithium has mass and no energy, specifically no kinetic energy. So simplify my life. Proton also has mass and no kinetic energy. By right, he has. Simplifying my life. That's the left-hand side. Will that be okay so far?
Mhm.
Now, magically they combine. Magically they combine without, any kinetic energy whatsoever. And then what happens is 2 helium-2 form. You would notice that the proton number is conserved. Please confirm that.
Yeah.
The nucleon number is also conserved. Please confirm that.
Mm-hmm.
So you would be tempted to think that the mass of lithium plus 1 proton will be equal exactly to the mass of 2 helium. You will be tempted to think like that. Would that be okay?
No.
And you are absolutely correct if you don't think like that. Absolutely correct. Then please explain what is happening then in terms of mass. I would love to say that you're correct, but there's 2 helium.
Oh, yes.
Right. Yeah. Okay. Yeah. Okay. Yeah, that's done. That's done. You correctly assume that the mass on the left-hand side should be bigger than the 2 helium because there's energy on the right-hand side. The energy must have come from the mass loss, so to speak. Right?
Okay.
It must have come from that. Now, what confuses you? We have been talking about this for the 4th time already. I want to drill deep, like what confuses you at first? Because you clearly know what to think after a while.
I just don't get it.
Okay. All right. But you did get it at the end. You did that one you did. So
It's just all the
what
MT,
is
ML, all the scary. I don't know what's going on.
the letters look scary lah.
Yeah.
At first,
I think
yeah.
it takes longer to like wrap my head around it, but once I wrap my head around it, I'm like, oh, okay, it's not that hard. Understand.
Have that mental strength that you already know what's going on. Whatever they're writing at you, that's just variation. Yeah, it'll be always the same thing. Right? Have that mental strength. Now, what's your next question?
That's something I'm fine. Eight, I guess. Eight is manipulation of formula though.
It looks even scarier, right? I guess it does look scary. Fair enough. It does look scary. Let's see. Or again, do read the question, and at the very least, if you could, you ask what you don't understand. That's a start.
Sorry. Getting water.
Yeah. It looks nice. Looks nice. Looks nice. Yep, that's fine. As you can tell, every option has over c squared. So what you're doing makes sense, right? Are you saying that A and C must be wrong?
Not entirely
Yes.
sure. Wait, can you hear me?
Sorry, you are requesting a hint? Yes.
Can you hear me?
All right. So observe the
Wait, no, I'm asking
situation.
for him. I'm asking, can you hear me?
I can now hear you.
Okay, I got it, I think. So you
Yeah.
add
Your answer would be
So my pen is not working.
right. You can tell me your answer.
You need Z times MP.
I guess that one makes sense, but everybody is Z times MP. So okay, I guess we got it right.
A times MN plus A times MP.
I'm sorry, which option are you referring to? Sorry.
A, I think it's A.
A, your option A, right? A, am I correct? A?
Yeah.
You would be correct. Any question?
Yeah, so I was kind of guessing between A and B. Why is it minus B over C squared?
So the issue about minus or plus, right? You have that two options, minus or plus. Now, the guy in front, the one that you are minusing it with, is the mass of the neutrons and protons separately, not combined in the nucleus. Am I making any sense?
Yes.
If, this is the principle, again, this is the physics, if you combine them in the nucleus, there will be a deviation of the mass. There will be. That's the physics that we are learning here. Let me ask you, when they combine to form a nucleus, tightly bound, very difficult to separate, right? Does their mass increase compared to the, separate, or does their mass decrease compared to when they're separate?
Increase?
I'm sorry, decrease or increase, sorry?
Decrease.
And therefore, that's the minus law. Finish. If that makes some sense.
Okay.
To be fair, this is correct because binding energy is presented as a positive value. So you minus a positive value. The principle still remains that it will decrease. Therefore, minus B positive value, everything works out. For all it's worth, you did choose the correct answer. So good job, right?
Yeah, I guess so. All right, then.
Next question.
Mine is D.
Yeah, unless you're interested in Y, That's a definition. We discussed this last time. Yeah. So just remember this, but remember it. Remember it. Right.
10 is C.
Wait.
That's 11 times 6.
Yeah, separate the nucleon. I guess that means separating everything. Yeah, so I guess that does make sense. Yeah. All right. Continue. The quantum. The quantum. What? This is now quantum physics.
Okay, 11. The following specification particle.
You really would want to refer to your notes here, lah.
D.
Oh goodness me! Oh goodness me! Everything is quantum up to
all the bosons. Bosons mediate forces.
6 things, lah. Yeah. Okay. Right.
Zero particles. Right. Actually, wait, no. Bosons are short range.
Actually, I kind of forgotten this already, right? Which one are they calling bosons? Right. No, because the exchange particles can deal with the strong, the weak, right? There are 4 forces, strong, weak, electromagnetic, and gravity.
Yeah.
Electromagnetic and gravity is long range, no? Yeah. Strong and weak is short range. I think that's how they categorize short and long range. So check your note again. I would butcher the formalities sometimes, but at least I know roughly what's going on. So if the bosons of the electromagnetic and gravity is called bosons, then it's not just short range.
Gluon is strong though, right? So
yeah, gluon is specifically for strong. Well, let me check again. My goodness, right? Okay. Gluon mediates what?
Yeah, so answer is D.
Yeah, strong. So yeah, gluon mediates strong. Yeah.
First, gluon, strong force and weak force are all short range.
Correct. So the W plus, W negative, and Z0 is the mediator for the weak, right? Good enough. So that's the short.
K boson is unstable, decay muon and neutrino. Okay,
they tell us the reaction. All right. And they even tell us the quark structure. Nice. So S is strange and anti-up, right?
So strangeness. No, charge.
Usually charges are conserved. Usually that it's very rare that charges are not conserved. And I don't think there's a situation where charge is not conserved. He will just tell you immediately that the strange number is usually not conserved. I'll just go straight to the point.
Yes.
Baryons, leptons, and charges are usually conserved, right?
So in this case, it's strangeness.
Most probably, I mean, the moment I see S on the left-hand side, I don't think I can see S on the right-hand side. I don't think so.
That's true.
So, and it's normal for strange number to not be conserved. But I don't know why though, right? I'm not that good.
Okay. Can
you seem to be comfortable with quantum. Wow.
Z naught, is that what I call Z0?
I have no idea. Z naught, I guess, right?
I think 13 will be D, because it can't be a photon. Because there's something mediating the change, right? So
this is not electromagnetic. I don't think so.
The charge is conserved, so it's not W plus or W minus. So Z0. What do you call it? Z neutral? Z0?
Sorry, what do we call it? I'm sorry, let me just Google that. I have no idea.
Oh, okay.
I have no idea how they call it, right? This is spelled Z boson, Z naught boson, call it Z boson. They keep calling it Z boson. Just call it Z boson. I have no idea. I'm so sorry. Right. Okay, 40. Oh,
Like electromagnetic, right?
I have to confirm. 14, I'm confused. Apologies. My quantum not very good. Let me just confirm one thing.
Because the electrons are like being repulsed
From each other.
right?
But that is an electromagnetic inflection, I suppose, right?
Yeah, so it should be D. It's not strong or weak.
Yes. No.
I don't think it can be electro weak.
Because electroweak always changes something. I guess we can say that. Yeah, I guess we can say that.
And I think it's
all right. Yeah. I mean, I am as good as you here, right? Okay. I'm just as good as you. No.
Oh God. Shall we skip this one? It's too tedious.
Are you sure you can do it? I mean, are you sure? I mean, after this is the last of the quantum, it seems like 16 is no longer quantum.
Okay, sure. Let's do it then. I'll use my finger to draw.
Right. Oh, the big right. Oh, they tell you the quark. That's nice. Okay.
Baryon number charge is violated. Right? Wait, no.
I wouldn't think so. I mean, a proton is positive, right? So again, I would be very hesitant to say that charge is violated. Like, I would very hesitant. So this, I think the strangeness is just given, yeah. So I don't think I will say charge. So is the baryon a lepton? No? So just calculate that, Not. I mean, it shouldn't be too inconvenient.
How do you calculate baryon number again? 1/3. Okay, quarks are 1/3. Right.
Yeah.
And anti quarks have -1/3.
Yeah, which means that all three is 0 lah, right? 0 baryon, right?
And proton has a baryon
1 baryon. 1. So, clear enough, right? Clear enough.
Okay, so baryon number is violated. So it's A. Yay. Okay, that works. Yeah, curiosity, lepton number is... Oh, lepton is for electrons, not for protons.
I'm so sorry, you're saying? I'm sorry? What?
Leptons are for electrons, not for protons.
Not for baryons, lah. I mean, baryons and leptons are exclusive, right? They are exclusive, lah, right? We are now changing topic lah for reasons. Are you okay? We are. Yeah. Okay, sure thing. Now 16 then. We haven't been talking about this for a long time, so oh goodness me, this is not necessarily an easy thing. Oh, okay, I can see Kiranya. Okay, so Daniel, I think we have to stop first. I'll see you later. Would that be okay?
All right, sure. Will you pick up where we left off?
Sure thing. All right. Bye. Kirana, I can see you. Can you hear me?
Yes.
All right, wonderful. All right. We can continue from the previous Jamboard if you want to. Sunday, right? Okay. Oh, we run out of pages, I think.
Yeah.
Right. Would you like to create a new Jamboard? And then
I can add page.
The maximum will be 20 lah. So do we is the Jamboard at maximum or it's no longer possible to add?
Okay.
There is an untitled Jamboard. I'm sorry. I'm sorry. Is that what you're referring to? There's an untitled Jamboard created by you. Only have 3 pages.
Oh, yeah, maybe that one can.
Shall we? Okay, sure. So I'll rename it. Okay, I'll rename it to
Yeah.
you. Right. So that it's not confusing. And then this is Kiara. Right. So I think we are on the same page. So page 4.
Do I
If the
update my Jamboard?
I'm sorry, you're saying?
Do I update my Jamboard?
What do you mean? Oh yeah, you want to update, right? So a very quick update will be nice.
Yeah, but like I know space like just now.
Here in page 4, you can. Here in page 4.
So I can update in page 4.
Yes, you can. I'm just getting the questions for you. Wait, submit.
Wait, but I got new questions.
Please do. As in the update questions. The update question. Oh, please ask your questions, of course. But here I give you the update question, and please ask all the questions you want. Because next Sunday and next Tuesday we won't have tuition. I mean, that is also the exam week. So, I told you that I'll be having a trip next week, right? So.
Yeah.
There are a few things that we can do. Of course, we can answer as many questions that you have today. That's one. But if you feel like you need an extra one, we can always do it on Thursday. That's another option, just to replace the next week.
Thursday I got CCA.
Yep. In that case, then the only time left is tomorrow lah. If you feel the need for the extra lah.
Okay.
Right. Okay. But for today, let's focus on just doing as much as we can, understanding as much as we can. True exam is coming. True that.
Wait, I trying to find my WA2 schedule.
That would be nice. Yeah, that would be nice. Yep, I can see you. Can you hear me?
Yeah.
All right, cool. Today will be the last Next week we won't be meeting because of my trip, right? Neither Sunday nor Tuesday lah. If I'm not mistaken, next week will be your exam week. Am I correct? Aryav, can you hear me? Yana, can you hear me? All right.
Yeah.
Okay.
I take my math textbook first.
Right. Do you have the WA schedule? You don't have? As a whole, as a whole.
Oh, my one is it?
Yeah. I mean, it's nice to understand the whole schedule. I usually try to do that.
Okay, yeah.
Because we don't just have exam for math now. Things might clash, so it's good to know everything.
Sorry, my Wi-Fi broke.
Right. Okay. So Arya, to remind you, next week, next Sunday and next Tuesday, you don't have tuition because of my trip. I told you last time, yeah? Exam will be next week, am I correct?
Yeah.
All right. So today, unless there is an extra for this week, today will be our last one before exam. Right? If you want extra, it'll be either tomorrow or Thursday. That's totally fine. Today, let's do our best and answer as many questions as you have. Do you have homeworks or questions to ask today?
No.
Right. On Sunday, your questions are good. Those are really exam levels. Is there anything else like that? Or is that done already?
That one's done. I submitted it to teacher already.
All right. So if tomorrow is the exam, let's pretend tomorrow is the exam. How ready are you, Arya?
Quite ready actually.
Quite ready? I would think so. Think about your preparation, right? Which you're quite ready. Think about your practices. Think about, well, your likely mistakes also, your careless mistakes. We are human beings, right? We will make those mistakes, right? Think about whether you're tired or not. Are you tired or not? Are you feeling fatigued or not? Got it, Kirana. All right. Think about all that, Aryav, and make a prediction. Make a prediction. What will you get for exam? A prediction.
What
I can see the schedule.
Exam.
Yeah. Make a prediction based on how prepared you are, how tired you are, what kind of mistakes you usually make. That kind of. With Kirana, I've seen the schedule. Now let's go to the question. Okay, interesting schedule. Yeah, and math will be here. Right?
Yeah.
And there'll be a labor.
I don't really.
Yes.
I don't know how much it is out of. I don't really know a lot about this exam.
True. Which is a bit weird. Do they even tell you how long the exam is? Like 30 minutes, 45 minutes?
No.
This is just for your information. This is always true, yeah? If it is 30 minutes, it'll be 20 marks. If it is 45 minutes, it'll be 30 marks. It's always like that one. So that's why by knowing the time, we know the mark already. Definitely one, right? But maybe you can make your prediction based on percentage, not based on how many, out of 20, out of 30. That's maybe you can just guess your percentage. Would that make sense?
I'd say I'll get like about out of 30, I'll get like 25, 26. Let's
say it's out of 30, right? So 24 is 80%. That is good, right? So you're saying that you'll be getting more than 80%. Correct, Arya? Based on your preparation, how tired you are, You may make some careless mistake. That's human being and all those stuff. You think you will get slightly more than 80%, correct? I'm curious to find out. I'm curious. Let that not pressure you, okay? Let that not pressure you. Now,
Yeah, okay.
Aryaf, today, do we do exam practice again? Because you're not super consistent in the exam practice. All right, then let's do the same thing, random paper, put in the question, discuss, and then do under time. All right. Hey, Kirana. So, you have the question, right? Okay, I'll make it big. Oh, you're make it big. Oh, wow. Kirana, can I confirm? Question 6, this kind of thing. This one is in exam, really?
Yeah.
Oh, my goodness. Your
Confirm in exam.
Confirm in exam.
Yeah.
Goodness me, question 6 is the hardest thing ever. Oh dear. Super, like it's super. But the good news is that the quadratic is
work example.
No, it's okay. I'll give you the bad news and the good news. The bad news is that reading and part 1 is the hardest thing. But the solving is usually kind of easy. Usually. Part 2 is usually what you did before this chapter. Correct or not?
What do you say?
Part 2. Look at part 2.
Yeah.
Part 2 is what you do before this chapter. You have done part 2 before. Correct or not?
It's the cross method, right?
Correct. And that looks easy for a cross method.
Yeah.
But the part 1 and the reading is the hard one. So it's both easy and hard. So you shouldn't be discouraged. You shouldn't be encouraged. Just take it like that. The first part is usually the harder one and takes some time. The second part is usually the easier one, something like that. Okay. Let's see what happens. Give it a try. I'll follow you.
I don't know how to do question 6.
Then do 6.2 first. As I've mentioned, 6.1 is hard. Everything in part 1 is usually hard. But 6.2 shouldn't be. Try your 6.2 first.
Okay.
In exam, you should be doing that, by the way. Do the easy one first. Understand? Let's try. Okay, Aryaf, you can use the Sunday Jamboard, if that pleases you. That would be good.
Yeah. Wait, so I'll use the last week's Jamboard?
Oh, no, the Sunday one. Okay.
Or Sunday one?
Yeah.
I already have a new one ready.
Then I'll follow you in the new one. No problem. Right. There you go. Right. Kirana, are you okay? It looks good to me. Looks good to me.
I don't know how to continue after that because the center is the 0. So
let me say first that everything here is correct. Yeah? Even the 0 is correct because there should be 3 things. Oh, there is no third thing. I consider it 0. There's no problem there. Now, 0 is not a very difficult thing to handle. Is something, remember, it should be, something times something becomes 0. Correct?
Correct. Okay. Wait.
It's quite easy to handle. Quite easy one. Try. Let that not. Yeah. One of them should be 0. Then that's it. That's it. That's how easy it is.
Yeah.
Cross method is doing fine. Arya, oh, you're typing updates, right? So just wait.
I can't type like I normally could type
Well,
because
what's going on?
I lost
Mhm.
my computer does not have a cursor
The
anymore.
keyboard.
No, it has a keyboard,
your,
but the cursor is gone.
why is the cursor gone? I'm so sorry.
I have absolutely no idea. I think it's because I jailbreaked my PLD.
Unless you want to update something today, we can skip updates. Like, let's just go to the exam training. Would that be okay?
Okay.
Kirana, be careful with your follow-up. Yeah, your cross method is cool. After that, you suffer a bit. Let's make sure you're stable there. Look,
Okay.
I did it for you. Understand what I'm doing. What you're doing is not okay. Yeah, what you're doing is not okay. But the cross method was finished properly, lah. Good lah. But after that, a bit wonky. Yeah, okay, not good, not good. Oh yeah, I can at least read your typing. That's good, right? I'm sorry. Why are you not in school, Arya?
Oh, I was sick, and then I went back to school. And then
Yes.
and then the last couple of days does not have math. So yeah.
Right. Considering all that, you still think that you're quite prepared. Am I correct?
Yeah. It's because in school I've already learned the topics
Correct,
like quite
correct.
thoroughly. The teacher's just teaching it again.
Correct. I am reasonably happy with your progress. Really, it was true also. This is now speaking exam mental strength. I feel that is your greatest challenge. I feel. Please, that's what we're addressing in our exam training. I feel that your skill is okay, but your mental strength can improve. Let's start our exam training. Kirana, are you okay?
Do we do door?
So let me explain. This part is not door. It's something else. This one is not door.
Oh, it's not?
This part is not. So going from here to here is not door. But after that is door. So this part is definitely door.
Like writing something because I cannot see.
I am. So there you go. So after the green is door. But that one easy to see lah.
Oh,
the green one is not
like,
door.
You need to change the sign because the number like goes after the equal sign, so like it has to change.
Even though that's how your teacher say, I will not say it that way. I will just say door. I will just say left plus 6, right plus 6. That's door lah.
Yeah.
Okay. I will not say moving. I will say door instead. I think feel door makes more sense. But the green part is not door lah, right? And the green part you have to write. Okay, you have to write that down. If you're not sure about it, please ask. Yeah, this one definitely will happen in exam 1. Okay, let's be clear about this. Yeah. I have just checking. You are doing the You're looking at the paper. Yeah.
Yeah. I'm loading into the paper. The WhatsApp, the Wi-Fi is really bad.
Yep, I do notice today a bit wonky. Understand. Aditya, I can see you. Can you hear me?
Yeah, hi, Mr. Phillips.
Hello, Aditya. Nice to see you. Aditya, just to remind you that next week there'll be no tuition because I'm on a trip.
Okay, yeah.
Will that be okay, Aditya?
Yeah, absolutely fine.
All right, understood. If you have updates, that'll be nice. And I'm itching to get into your differentiation again.
Okay.
Okay, Kirana, yeah, that is what you need to write. Kirana, so far so good, yeah? Are you sure no question for part 2?
No, I can check the answer if it's correct.
Okay. Now, if you can do part 2, you can do part 3.
Oh, okay.
So do continue to part 3 afterwards. Make sure that in exam, you can at least do part 2, part 3. That's already more than half the marks, I think. Ditya, are you okay?
Okay, it's correct.
Now, try part 3, Kirana. Again, I say to you, if you can do part 2, you can do part 3 one. Give it a try. See whether it makes sense for you or not. There's a lot of reading and understanding, comprehension, and your English is not bad, right? Okay, Aditya, I can see your video. It looks very nice. Aryaf, are you okay so far?
No, it's still loading.
It's very slow, isn't it?
Yes. I'm actually
Okay.
really surprised why it's loading
Right.
slow.
Right. So Aryaf, let's not waste too much time, right? Because it's for your exam. Have you read the question? Have you read the question and decide whether you want to discuss something? If there is really something to discuss, then we wait low until the question shows up. But if
No,
not,
I cannot even load into the paper. It's still loading.
oh my goodness, that's just so bad. Which paper do you choose? Let me try to do something about that. That's just bad.
Oh, I don't remember. So I cut it. It was loading too long, so I cut it, and I'm going into my Gmail again, and I was lagging in my Gmail.
I'm gonna do something about that.
Okay. Wait a second. Oh my god, it's really bad. Oh my god. Oh my god.
Yeah, Aditya, I'm gonna choose for you. I'm gonna choose for you. Geylang. Would that be okay? SA1 Geylang, right? Oh goodness me, it is slow, isn't it? Yeah, for some reason, Drive is slow today. Something is going on. Yeah, I got Geylang. Okay, I'm putting it in a Jamboard area. Okay, I'm putting things in the Jamboard from Geylang. Area of graph drawing not included, right?
No.
Right. Okay, can you see the questions I put in the Jamboard?
Yeah.
Okay. All right, so that's from paper 1. I'm going to go to paper 2.
Is the answer correct?
I'm sorry. Okay, you cannot check the answer key, isn't it, for this one?
I don't know, but if I calculate, is my calculation correct?
Okay. Well, I think for part 3, what is important is your logic, your logic and calculation. Right? So now you're saying that Imran's father now is x squared. I guess that makes sense. So it must be 36, right? And then now I'm not sure what you're doing here, but I understand that Imran's father is 36, correct?
Yeah.
And what is X? X is 6. So right now, Imran is 36. Imran's father is 36 and Imran is 6. That's what
Yeah.
you're saying, correct?
Yeah.
So I'm not sure why you do 36 minus 6. Can you tell me why?
Because they say to find the age of Imran's father when Imran was born, so just minus of the age.
That's your logic, right? That's not formula. That's the logic, right?
Yeah.
I can understand your logic. I think it's fine. Right? That's why I asked why. Why? I think the why is important, right? All right. So there you go. Feels good. To answer part 3, it requires logic. Surprisingly, to answer part 1, it also requires logic. So Aryaf, are you seeing my questions?
Yeah.
I'm putting them already. All right. So yeah, there's quite a lot here. No. Read first, order first, remember all those stuff, and then total, and then you set your timer, right? You'll be doing it under timer, right? Okay. Under timer, but not under pressure, right? That's the thing. Under timer, but you have read everything, you have planned everything, so you are having less pressure. That's the idea. Okay, I think I finished already, so I put everything on. So make sure you read everything. So Aditya, I see that you're typing, but I'm not seeing anything. Are you doing something in the Jamboard? You are. Okay. Okay, so got it, Aditya. Now, Kirana, I'm going to ask you to skip the part 1, really. It takes a long time. Okay, I'm going to ask you to do a few questions, part 2, part 3, part 2, part 3 first, and then maybe we'll go back to the part 1 and then discuss. Does that make sense?
Okay.
Okay, I'm going to make sure that you get the easy part first. Right? Okay, got it, Aditya. Endo. Oh, I thought it's endo.
I actually need to do a graph question for my homework.
Is it part of exam? Yes,
yeah, definitely.
Then it's okay, Kirana. You can practice that if you want to. Yes, Arya?
Okay, I take picture.
It's lagging
Yes,
so
please.
hard, I can't change pages.
The Wi-Fi is just bad, isn't it?
Yeah.
Can you go out where the Wi-Fi is good? Unless the Wi-Fi is just so bad, then you better use your 4G or 5G. Make sure that you get it because we cannot proceed without it. Go somewhere, go outside or borrow your 4G, your father. Make sure that you can read everything. Would that be okay? Is that okay, Arya? Can you hear me? Arya, can you hear me?
Hello.
Yes, can you hear me?
Oh, wait, I'm changing my room.
I understand your update, Aditya. I understand. Knee pain and ankle pain. Oh, goodness me. Tell me again, why is there a knee pain and ankle pain, Aditya?
Basketball, jiu-jitsu.
Oh, this is quite long already, isn't it? This is 1 month already, right?
Yeah.
Oh, that's not fun. Oh, goodness me. Right. We got it. Right. Can you still do tuition today, Aditya?
Yeah, it's fine. Like, it's all good.
It's all good. Then I'll be praying that you'll get well perfectly. I think you want your knee and ankle to go back to its original strength.
Yeah, because I've got trials for team coming up. I think at the start of next month. So if you get better by then, or else it's going to be tough.
your doctor or Ayurvedic doctor should also be advising you to not move too much, lah, right? I mean, it should be a total rest lah, for your leg. It should be lah, right? Hopefully you'll make it there. Yeah? Hopefully. Okay. I'll be following you through video. Now, Arya, can you hear me?
Yeah, my Wi-Fi is better now.
Okay. Can you see the question?
Mm-hmm.
All right. So make sure you read everything. There is no rush. This is not a time to rush. Read everything, total everything, discuss everything. Only then you start.
Okay.
Kirana, are you? Oh, yeah, you're doing good. Okay, I understand. But Kirana, I thought there is no graph in the exam. No?
There is.
Goodness me, why there are so many new topics the week before exam?
This is not new
What?
topic. It's from chapter 5.
It is? You never
Yeah.
asked me about graph.
I did. I told you that we're learning on quadratic graphs.
Okay. We'll cover more and strengthen more in June, okay? After exam. No, in May. Right?
Okay.
Yeah. Okay. But I'll follow you today. Yeah, are you okay? I'm not seeing anything yet, yeah?
Teacher, what's the marks for question 5?
Questions from virtual deck. Oh, the file is gone. Right, let me get that for you. Remarks. I'm gonna write it down for you. And now, okay so far? And okay so far? Yeah, are you okay?
Yeah, just pulling out the questions.
Has differentiation increased? You're saying?
Sorry?
You're saying, sorry, you're saying. Yes. Okay, yes, you're saying.
No, just getting the pictures.
Right. I was trying to ask you, has differentiation increased in difficulty?
Oh yeah, by a lot. Oh my god.
Yeah,
Our teacher gave us
that's
a practice paper, and
right.
like more than half the class, it was out of 31, more than half the class got less than 10.
That was one.
I got 16 though.
16 is it's reasonable for now. Was waiting for that time. Waiting for that. Oh, okay, got it. Aditya, do you have any question for 12? Or you're just putting things in?
I felt like putting a bunch of them in because
Sure. No worries.
like next week we can just use them again.
Right. But do remember that next week we don't have tuition.
Oh yeah.
Yeah, but you can still put them in. Right? You can still put them in. And if you have an urgent question, I will still be able to answer like using WhatsApp. Urgent matters can. Yeah. Arya, have you read the question? What do you think of them? That's quite a lot.
Yeah, I'm all right.
You think you're okay? Your reading is good. Your planning is good. You think you can do it, blah, 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 yada, yada.
Yeah.
Are you ready to do them then?
I'll
sorry.
sign a minute.
All right.
Okay, you can't hear me?
Just now cannot. So how many minutes are you supposed to have? Quite a lot, apparently.
Sorry, a loud motorcycle drove by. Could you say that again?
How many minutes are you supposed to have?
So 10, 16, 16, 18, 21, 21 plus 6 is 27, then 27 plus 14 is 41 minutes.
I agree with you. Yeah. Do continue beyond the tuition. Yeah, your 41 minutes, just back through them, right?
Okay.
I tell you the paper so that you can check the answer key later. I mean, you're supposed to check the answer key for marking, right? So it will be 2014 SA1. Yeah, this is SA1.
Yeah.
From Geylang, paper 1 and paper. Whenever you're ready, then you just time yourself 41 minutes and then go for it. Aditya, do you want to ask any questions? I'm sorry, you're still putting them. Okay, fine.
Yeah.
No, they now look like exam level, like finally. Wow. Totally different from what you did last time, right? Just totally. Just totally. Yep. Final.
Just like the whole end of chapter review.
Which is fair, I think. It is fair. the questions are fair in that I think it will represent exam. Yeah. It would do us good to understand them. Do us good. Okay, shoot your questions whenever you're. Kirana, are you okay so far? You look busy, so I assume you're fine.
Yeah.
All right.
Oh, can I take my my curve ruler?
I'm okay. Yes, of course. No questions, yeah, Aditya, just to confirm.
Nope.
Okay.
Yeah, no questions. Not really.
Aditya, would you mind zooming in, please, so I can follow?
Yeah.
Arya, I would suggest that you do on paper, yeah? I think paper is always faster, yeah? Just saying.
Okay. I'll bring my paper.
Sure thing. Do pause the timer first. Aditya is question. Yeah, I'm not following you well. You're doing question 2.
Question
two,
two.
right? Okay, got it. Okay, got it. Okay. Now, do you need to do question 2? It seems basic to me, but if you want to, I'm okay.
I think I'll try it because it looks a bit like something that I
Okay.
would mess up in.
All right. All right.
Because it's always like, oh, it's simple, and then you mess it up.
Fair. But you don't want that in exam. Fair. True. True.
Just a quick question. When is my brother's tuition?
Should be just now. I guess the latest he can enter is 9:15. Yeah, so yeah.
Okay.
For you, although the tuition time is officially ending, but you just power through the exam training. Just power through it. Yeah.
Wait, so I'll leave after my exam training is done? Or
You don't have to. You can even leave now if you're ready. It's okay. Because you can just update me later lah. I mean, anyway, next week we're not meeting lah. But because during exam training, I'm not supposed to help you, ma. Correct or not?
I'll just send you WhatsApp.
Sure thing. But before you leave, remember, I'm not supposed to help you during the exam training, but I can help you during the discussion. So confirm, no discussion needed. Just to confirm.
Yeah.
Then feel free to leave, use paper, time yourself, and I'll see you in 2 weeks' time.
Okay, bye-bye.
Bye-bye, Aya. So Aditya, you're at least using the product. Oh, goodness me, right? Okay, I'm gonna, okay, oh wow, right, okay, we really need to discuss this, isn't it? Jamboard, please. So Aditya, for the U prime and the V prime, are you looking at the Jamboard?
Mm-hmm.
There's a basic skill that you'll find. Your chain rule is just off, both. So you're both wrong, but not wrong fully. You're missing something. The chain rule issue. Chain rule. Both has the same mistake.
It should be -2 sin x. And there should be
Yeah, you forgot the 2, and the other one, you forgot the?
-3x to the power -4.
No, it's just 1/3. Why so complicated? Why so complicated? This is basically 1/3x, ma. 1/3 is just the same as 2, ma. Right? Agreeably, that's basic skill, so a bit disturbing that you don't do it right. Fair enough. Are you sure you understand what's going on here?
Yeah.
All right, then fix it. You don't have to scratch everything up, but do fix it. Yorana, if you don't mind, you don't draw the curve here. I know that it takes time, right? Unless you have a problem and we can discuss, I prefer that you don't do the drawing here because you can do the drawing outside tuition because time is almost
Oh
out.
no, then right, like this question, they ask for the coordinates, so like and then
You have to draw.
The answer key, but I don't provide the answer, so like I scared wrong.
Fine. So you can draw. Oh goodness me, there's so many things. Okay. You do you. You do you. Hey Aditya, do fix it, please. Come on.
Yep.
Don't take too long. Right. Kirana, this is a serious opinion, I guess. Have you tried drawing without the ruler? You freehand the thing. Have you tried that? Precisely. Because you know what a quadratic graph is supposed to look like, right? You do know that, right? Some people can actually freehand very nicely. Not everybody, but if somebody can do that, that's the fastest way of doing things if they can do it correctly lah. Have you tried freehanding? Right, but freehand means you have to be flexible lah. You have to be flexible lah. You don't go rigid lah.
Because like my teachers say, like the line cannot be squiggly. So like,
I know. So when they freehand, after a while, they get so good at it that they don't sweep one. They just go one up. Work like that slowly. They do go in a steady pace, not too fast, not too slow. I don't think speed is the important thing. I think accuracy, but they can do that. And when they freehand, they do what you did. Sometimes they just flip the paper 90 degrees because it's easier to freehand like that. So when they freehand, they rotate the paper instead of our hand, if you get what I mean. That's a lot of ways of how people freehand and still get a very good graph. Like it's so good. But some people are. So my feeling is that you are the type that can do that. So I might be wrong, but after some practice, you might be super comfortable with freehanding. The only way to know is to try lah. So you're currently trying, right? But remember, you can rotate the paper. Your hand and your paper must be in a very nice position, right? You don't force it into contorted position.
it's my free hand.
Your right side freehand is very nice one. Your left side is just totally off. Like it looks like there's something wrong with your like there's something wrong with your points on the left somewhere. Could you check the leftmost point? It looks like it's something off. That's why it's messing up with your graph.
Okay.
I mean, it doesn't look like it, but yeah, I think I know where your mistake is. You make a mistake for your left-hand side one. You check your points. Your points on the left-hand side, one of them is wrong.
Like, if like cause this is the
Oh
like the
no. This graph is very difficult to draw.
Huh?
Oh no.
What?
Why is this? Oh, serious, man. Now, Kira, listen to me carefully, yeah? This graph is very difficult to draw. The reason is because the points are not symmetrical. This is one of the hardest graph to draw. Like, it's super hard one. First, and anyway, you miss the -5 wrong somewhere. You also make a mistake. I don't know why you crossed to -2 there. That's just totally off. It's really totally off, you know? It's 0 minus 5, man.
Oh wait, I redo.
Yeah, so you messed that one up. Then your P, what's the P supposed to be?
-10.
At least your P seems correct lah, but your -5 is totally off lah. That's why that's why it's messed up.
I put the thing wrongly.
Maybe you did mess up there lah.
Yeah.
But beyond that, the graph is difficult because it's not symmetrical. Wow, crazy, man. Wow, this is crazy, man. Like, I don't expect this to appear right now. Oh dear, oh dearest me. Well, this ain't good. Okay, use your freehand first lah, properly first lah. I think freehand is your best bet. Hey, your -5 still off, you know? What's going on here? Is 0 minus 5? How come it's so off, yeah? It's off again.
Wait, but it's like if it's 0 minus 5, is the thing supposed to be on the 0?
It's called 0 minus 5, man. If that makes sense, it's 0 minus 5.
But is the value supposed to be on the
Look, why are you going to 0, 0? That's not called 0, Kirana. What you're going to is 0, 0. You're supposed to go to 0, minus 5. That's not 0.0, yeah? That's 0.0, 0. Hence the misunderstanding.
Okay.
Aditya, are you okay? Oh, you're doing
I think so. I think so.
Do you mind shifting your camera so that I can see more of the right, so you don't come out of, if it is possible for the camera to shift to the right? so I can follow you better. Yeah, that works. So you're using the quotient rule. Let me see your quotient rule. That looks great. Yeah, everything looks great. Except no, that's fine. That's fine. So you don't know how to simplify, right, Aditya?
Do we have to? Like, I
All
love
right.
to
Now
like this in the practice paper
here's
and my
the
teacher said that's okay.
yeah, I will agree with you, especially that in exam, if this is exam, it's not always the case, but it's usually the case that the question don't stop here one. This gives you the impression that the question stops, right? But
Yeah.
usually no. If the question doesn't stop here, it is totally not required to simplify because you can use it anyway for the next step.
Yeah.
But this question seems to stop here. So should we simplify or not? Frankly speaking, in exam, I will worry about other things first. I will stop here, do other things, and maybe get back here and think about it afterwards. I will do that. Right? I mean, it doesn't look very friendly anyway, right?
Yeah.
Yeah. So I wouldn't bother about it right now at this stage. Please, your application is good. Let's do the next question.
My graph's a bit off right now.
Why do you have 0 minus 2? Stop labeling the 0 minus 2, please. That is very confusing, isn't it? Why is there 0 minus 2? There's no need for that, right? Okay. So let me see your 0 minus 5. The 0 minus 5 is fine. The 1 minus 1, 6 is also fine. I really think you need to freehand here. I think that's a better way. Your 1 minus 10 is also off. Really, your 1 minus 10 is very off, isn't it?
Where is it?
It's supposed to be 1. What is your P? Where is your P?
Yeah.
P is supposed to be minus 10, right?
Oh.
It doesn't look like minus 10 to me, so that's off. Oh, this graph is not good. This is wasting our time, for example. I'm going to show you why. Okay, this is not a nice graph at all. Oh, Keiko, I can see you. Right, Keiko, can you hear me?
Yes.
Right. Apologies. Sorry. I was assuming that you're on Thursday. I have forgotten something. Do you want it to be today?
I'm okay with anything actually.
If you don't mind Thursday, that would be probably easier for everyone. Here today definitely crowded. Today definitely.
I see. Okay. Then I'll go on Thursday.
Thursday. Thank you very much. I'll see you on Thursday. Bye-bye.
Bye-bye.
Okay, Karan, I'm going to show you something. Right. So, Aditya, you're doing question 3. Right? Moving on, Aditya, moving on. Finally. This kind of thing.
It's pretty hard. I don't even understand what they're trying to say.
Fair. Question 3, I've never explained to you anyways, I'm all right. Anyways, I'm off. Okay, question 4, also not yet. Okay. Scary, right? Now, can I ask you whether you can do question 5 first? Question 5 at least. Oh goodness me! Nothing is easy here, isn't it?
Yeah.
Wow! Suddenly, there's a
Our
big
teacher
jump, right?
assigned us these questions in class, and the only thing for that lesson it was just practice, and the only thing he said was, do question 1 to 6 if you can. Good luck.
I'm supposed to explain all of this to you. This is like the local school kind of rate, and so you feel like that suddenly it's very easy, steady, basic, and then suddenly it's a jump. But we are supposed to be there. We're supposed to be here at least before the IGCSE. Now go to question 7 first. 7 probably still doable for you. I think 7 you can. Okay. The rest of the question we better understand together, whether in class or in tuition. We better.
Okay.
We'll take it slow. Okay, I got it, Kirana. So I'm going to show you something, right? Okay. Kirana, you help me read the coordinates for me, please. I'm doing something so I can help you. Read the coordinates for me, please.
Yeah.
One by one, yeah.
Okay, wait. Okay, so it's like
minus 1, 6, 6. Then
0, minus 5.
All right, then
1, minus 10. I mean, it's supposed to be P. But
right, understand. Then
2, minus 15.
oh goodness me, your minus 10 is wrong. Your minus 10 is wrong. Uh-oh, that's why you're off. You make so many mistakes that the drawing is impossible. Your minus 10 is wrong.
What do you
Check
mean?
your minus 10 again. Check your minus 10 again. Your P is wrong.
It's on.
Check it again.
Also, the value is wrong.
Yes. How did you get that?
Wait.
That's why your graph is messed up.
Yeah.
Aditya, are you okay with question 7?
Yeah, just reading. Just reading.
All right. No wonder everything is messed up. No wonder.
Oh, it's supposed to be minus 12, I think.
I agree with you. Now, suspect an error when this happen in exam, when the graph is just not, happening, right? You understand me?
Yeah.
Suspect that. I mean, be open to our own mistakes, right? I mean, we're human beings, man.
Yeah.
We make mistakes, but we can suspect that is happening. That will, prevent it from making things worse, right?
Yeah.
We can be frustrated, but we shouldn't be stuck by it,
Yeah.
Okay, I'm continuing, right? So at this point, you will probably be able to do it better lah, because I think it matters a lot, right? That should matter a lot. Now you try your drawing first, and then you look at the Jamboard lah. I've presented to you something. Okay, Ayash, can you hear me?
Wait, yours looks so different from mine.
Probably it's just a bit squished. Never mind the squishiness. Perhaps just a bit squished, right?
Okay, I think mine is probably correct because it's quite.
Yeah, mine. Yeah, yours are better already. Right.
Okay.
So notice, your drawing is actually quite good. After you fix that, your drawing is quite good, and your freehand is not bad, right?
Yeah.
I see you have difficulty using the ruler. I don't think the ruler is a very nice tool anyway. I mean, your freehand can improve, yeah, but it will improve with practice. Whereas the ruler, sometimes, no matter what we do, cannot improve with practice. Your freehand may improve with practice. It may.
Okay.
It may. So maybe you should try freehand for now, so that you keep practicing them.
Okay.
Ainash, can you hear me?
Yeah.
All right. Okay. So, Ainash, this is to repeat our discussion last time. Tuesday is crowded. So I was making the suggestion that you move to Wednesday or Thursday. But you basically like the suggestion. So if you don't remember, I remind you that. Do you still want to stick with Tuesday? Or do you want to move the Tuesday one to Wednesday or Thursday?
The thing is, I can't confirm that I'll be free every Wednesday. So if you're okay with like a flexible slot, so some weeks Tuesday, some weeks Wednesday, then okay. But
Then,
if not,
then for now it's fine. For now it's fine. I mean, better than nothing, right?
yeah.
So for this week, like today lah, Tuesday or Wednesday?
Today I can Wednesday.
All right. Then I'll see you tomorrow. Probably a better day. Now, is tomorrow a better day? That's actually the question lah. Than today lah.
I mean, it's the same situation as today. Actually, no, tomorrow is a better day.
Then I'll see you tomorrow. All right.
Bye.
Okay. Bye. Okay, Aditya, how do you start? Aditya?
Lightly.
Okay. Now listen to me carefully.
Yeah, a bit stuck.
All right. Then let me settle things with Kirana. Now, Kirana, by right, our tuition is all over already. Yeah? Do you need to ask any last question?
No.
All right. Then urgent question you can ask, okay? Urgent question you ask using WhatsApp, I will answer them now. Because remember, next week don't have.
Okay.
If you feel like extra, you come on Wednesday or Thursday anytime you want. Understand?
Oh, okay.
Okay. All right. You don't have to tell me, just come tomorrow, then I will be with you. Right?
Okay.
Okay. And Kirana, remember, any urgent question, please ask. You can also ask your father to ask. I will answer. I'll see you in the next 2 weeks.
Okay.
Bye-bye, Kirana.
Bye.
Okay, Daniel, I can see you, yeah? Let me settle things with Aditya first. Now, Aditya, listen to me, yeah?
Yep.
The graph may look confusing, but it's just pi, okay? It's just plus pi over 3, nothing fancy. Pi is a number, so don't be afraid of it. Now, you notice that the graph gives you half a point, meaning he gives you the x coordinate, he doesn't give you the y coordinate. Am I correct?
So I have to sub it in. Oh my god, that was
yes.
Sorry,
that was the question. No, that was the question messing with your brain, correct?
Yeah.
The moment I interpreted it to you, you have the skill. I know you have the skill. What messes you up? It's the reading of the question. Do you understand?
Yeah.
That means part of the challenge is to read the question so that your skill can be used. I mean, to be fair, your skill is there. It's just that the reading messes you up. So hopefully you can do part B. Now, Daniel, I'm ready. Yeah. So, oh, wait, your Jamboard not yet. Okay, so going back to, so which question should it be now? Daniel?
Oh, Mr. Phillips, another question.
Yes.
Is it sine of x plus pi over 3 or sine of x plus pi over 3?
Oh, the plus is outside the sign because there is no bracket.
Oh, okay.
Does that answer your question? So you bracket close now, lah. Yeah. Okay. You have a 2, okay? Careful, you have a 2. Don't mess up with that.
Yeah. Oh, yeah.
And your calculator will not help you, Your calculator will not help you. You know what? Because he wants it in terms of pi, Correct. So don't do that. And you don't need it anyway. You just need it for a certain part. Now, Daniel, can you hear me?
Yeah. Hello.
All right. Are we going to question? Question. Okay, I'll see.
17.
17. Sorry, wait. Let me. Why is it so difficult? There you go. Okay, there you go. So, we are not doing 16. No, we're not.
I understand 16. You want to go through 16?
No, it's fine. If you understand, then all the better. Right?
Yeah.
Okay. What is your question with 17?
No, this one is out of phase. But at which period? At which difference?
Oh wow! I seldom see this question being asked in local. Okay, cool. All right. The out of phase of of the magnetic flux and the EMF induced. Wow. I mean, this is more like it is more like a memorization. It doesn't change with situation one. It is always out of phase in a certain way lah. In a certain way lah. So if you know, you know lo.
Is it
Like what I'm trying to say
quarter?
is if the note tells you, I can tell you that a third and a half is not that. So usually they will confuse you by a quarter or three quarters. So at this point, they are being very fine here. Right? Why don't you just check your note? Why don't you just check your note? Just make sure that your note tells you that you know, okay, this is going to be something I need to know. Okay? Might as well just revise it.
What chapter?
Usually
is
they,
this,
EMF induced will be Maxwell law and Lenz's law, usually, where they talk about the two laws. It's quite late in the EMF series, quite late.
11.3.
I don't remember looking at this slide in your slide. You know, I don't remember it. Wow, I don't think
It's not
tell you.
capacitance.
No, it's not. No, it's before capacitance. Nothing to do with capacitance.
Okay, let me scroll through and see what I can find.
I don't remember that your slide tells you this. Oh, what's going on here? Hopefully I'm wrong, right? Either they tell you or they don't.
Alternating current, flux linkage, and rate of change of flux and induced EMF.
Okay, all right.
Let me screenshot it and put it in. Put on page 5.
Put it on page 5. I'm sorry. Put it on page 5. Right. Okay. There's a page 5. Okay.
Is it this?
Let me see. Oh, maybe. Yeah. Okay. I'm gonna make it bigger. Okay. We don't clash. Nice. Yeah. See, you have the induced EMF. So never mind the rate. Yeah. Just ignore the rate thingy. You have induced EMF and you have the flux, which is changing lah. So flux is the the source or the originator, and then you have the induced one. Now, how out of phase is this? How out of phase are they?
It doesn't say explicitly.
No, but you can see it. What out of phase is this?
A quarter.
If you could, yeah, okay. I'm just going to confirm that with you, right? So even a quarter can be a quarter in whatever direction, but I'll just make it very easy. This thing is comparable to this thing, correct? Correct. We compare the peak with the peak lah. That's one way to know. And this is definitely 1/4 wavelength lah. Definitely lah. Correct? There you go. That's your answer lah. I'm not going to say whether this is lagging or in advance lah, but just keeping it simple, that's 1/4 lah. That's 1/4.
So they may ask, like, is it ahead by 1/4 or behind by 3/4?
Yeah, they can. If they know they said ahead, then we are wrong with 1/4. They are ahead by 3/4. This question is nice enough to not involve that lah. But other question. It can further complicate things in a acceptable way lah. What else can I say? But yeah, this picture is there. Therefore, confirm your syllabus will be interested in this lah. I guess lah. They're not interested in the local side lah. Good to know. So Aditya, you're getting it well. Yeah. I will. Right. So you get your differential. Oh goodness me! Oh my goodness! Your dy dx is wrong, Aditya. I will be very concerned right now with your dy dx. I'm extremely concerned right now. I think the question successfully confuses you. Now, hear my hint. Do you need a rule or not to differentiate?
I think this one requires chain rule, right?
No, product rule.
Oh yeah.
You didn't even spot the need of the product rule. Now that's concerning because that's clearly a multiplication of x with sine x. Now that is a little bit concerning. That's a little bit concerning. That should be good, but foundation-wise, right. You pay attention to it. Now, Adanil, which next question?
18, I guess. 18 would be B, right? Because this inverse.
You're talking about not exactly being the same, right? That's what you're talking about, right?
The opposite. So inverse is the wrong word. It's the
opposing. Lancelot. Opposing.
Opposing. Sorry. Wrong. Opposite lah.
Oh dear, I'm currently worried. I know it. Wait, everything. Oh dear. Okay, so the question has successfully fooled you, yeah? The answer is D. I'm so sorry to say that.
For 18.
It's D. Okay. You got all the principles from you don't understand it.
What is it, D?
Okay, so Maxwell law, right? The induced EMF will be proportional to what? You better understand this. The induced EMF will be proportional to the what?
Your voice kind of died. What do you say?
The induced EMF is proportional to what? Better check your slide.
Lenz's law.
Lenz's law is the opposing one. No need to worry about Lenz's law. It's Maxwell law or whatever you call it. Usually the formula induced EMF equals to something. What is that equal to? Okay, Aditya, your product rule is correct. Yeah. Right. Okay, now you can do that.
Induced EMF equals minus and change in magnetic flux over change in time.
Good. Change in magnetic flux. So d flux dt, right?
Yeah.
D flux dt. And inside the flux, there's a B, right? Because flux is BA, correct?
Mm-hmm.
So it can be dB dt in this situation. Right. So still not getting it? The rate of change of B is what matters, dB dt. Not the shape of the B graph. The dB dt is what matters.
Oh.
The gradient is what matters, not the shape of the graph. You're missing the point there. This is a very important principle. This will always happen one. Be careful.
Differentiate B respect
dB, which means the gradient. In terms of graph, it is going to be the gradient. Understand that, right?
Okay.
That's math, man. That's the math part. As you can tell, the gradient of B is going to be a line, another line, a line, another line. The gradient of a line is constant, right? The dB dt is constant for one line. So therefore, the graph of EMF will look like D. Does this make sense or not?
Yeah.
This needs to make sense. All right. This needs to make sense.
Oh, I thought it was just opposite.
Totally wrong. Totally wrong principle, yeah? It's totally wrong principle, okay? What you're quoting is totally wrong, okay?
So Lenz's law is for
opposing the direction. The direction of the whatever induced EMF. Yeah, no, not here. You don't apply it here. You don't. That it's just off. It's just off. Let me put it another way. The Lenz's law is appearing here. Look, the gradient of the dB dt start off positive, correct or not? They're all positive, right?
Yeah.
Look at the EMF. The starting on the air is negative. There's your Lenz's law. If you want to do it, you do it that way.
Okay.
So supposedly the gradient is positive, my EMF is negative. Supposedly the gradient is negative, my EMF is positive. No? That's how to do it.
Okay.
What you quote just now, let me repeat, is not going to be right anytime. So be very careful with that because it's tempting to think like that. Good, Aditya. Good. So you're already at MN. Yeah. Hey, Aditya, because I cannot follow down, are you done with question 7? Right. Okay. Is there any way for you to check the answer key? I mean, the half looks about right, lah. So it's just a matter of calculation, lah. Can you check the answer for 7? Yes.
Yeah.
Right. What is the next question, Daniel?
19.
Okay. So, okay.
Is
Sure.
it constant or varying? The direction I get, the direction I understand, but the current, whether it's varying or constant, it feels like a trick question, you know?
No.
The magnitude is decreasing at a constant rate. Right?
Right. The magnitude, yeah. Okay. So that's
Which means
dB/dt, right? It's dB/dt, right?
What?
Correct or not? You're not thinking about dB/dt, you're not thinking about deflux dt. I'm a bit worried.
Huh? But okay, this is with time, what?
This is induced EMF.
Yeah, that means the current is varying, right?
Wrong. Again, let me repeat. You don't think about defluxivity. You don't think about dB/dt. You don't think about EMF equals to dB/dt in this case. It worries me. You don't get the main principle.
Should I be thinking about it or not?
Yes. Oh, goodness.
Okay.
It's just the same thing as question 18. You're not thinking about the central principle, the central physics.
Okay.
That is the thing to address here. First of all, this is induced EMF. They don't tell you, right? They don't tell you this is induced EMF. That means you weren't thinking about induced EMF because they don't tell you. Now that already worries me.
Okay.
Is this induced EMF or not? I'm asking you lah.
Yes.
Why is this induced EMF?
Because a magnetic field is perpendicular to a conducting wire.
That is so not induced EMF. Yeah. No. Induced EMF equals to deflux dt.
What the hell are you asking? I don't understand.
If I don't tell you this is induced EMF, would you think that this is induced EMF?
No.
That's the problem. That's why I'm trying to ask you, why should you think that this is induced EMF? Not because I say so what. That doesn't work well in exam.
Okay.
Oh goodness me, I'm asking you. Yes. Okay. Like start thinking. Like when is induced EMF a thing, right? When is it? According to the formula, it's where there is a deflux dt.
Okay.
You don't see a deflux dt here, isn't it?
I see flux and I see time.
Do you at least see dB dt? You know what you are looking for, not what I'm looking for. Do you see the dB dt?
No, I do not.
The question tells you straightforward in your face. That's why I'm worried. The magnitude of the magnetic field is decreasing at a constant rate. Wait, that's dB dt, what?
Okay.
I'm gonna write down in the algorithm, right? Right, I'm gonna write down in page 6. Now, Aditya, are you ready for the next question?
Yeah.
You choose one between 8 and 9. Just one. 8 and 9 is similar. Try to be able to do that correctly. Then we'll move on to the weird looking ones. Choose one. Only 8 or only 9. Right?
Oh, okay. Let me see.
I'm writing a formula straight from your slide. Will this be okay? In the Jamboard, page 6. Daniel, page 6.
Yeah, I'm on page 6.
So the EMF is this formula. I'm concerned with this formula. This is the crystallization of the principles. Will that be okay? Let's start with this. Right. Then according to this question, I noticed that the n is constant, so I don't worry about it. And it's just one loop, so that is constant. Now, I see no mention of flux, but I see a mention of magnetic field. So I'm happy because will this be okay?
Yeah, I guess so.
The n is constant. I also noticed that the area in this case is not changing. Okay, so I put it as constant. Would that be okay? Still math at work. I push the A out. I'm just dB/dt. And I do notice that the question mentioned dB/dt. So I'm happy. I'm happy. Right?
Okay, so the
question
question says it's decreasing at a constant rate, which means dB/dt is 0.
That is not making any sense. If
no,
dB/dt is 0,
the gradient is
constant.
Linear, right? Constant.
Correct. So the gradient is something. The gradient is something, not 0.
Okay.
Let me check the direction. Let me check the direction. Just check the direction.
Counterclockwise should be D. Sorry, D.
I will be checking that also. Okay. I'll be checking that with Lenz's law. I go very slow one here. If I'm doing this as an exam, I go super slow just to make sure I'm correct. I'm gonna check.
Okay.
The uniform magnetic field is perpendicular and the field is directly out of the plane. Okay, I'll do that. So out of the plane means I'm looking at the tail, right? So this is the B, right? Right. So Lenz's law say whatever EMF whatever EMF is generated or induced, it better oppose the original thing. Right? So the EMF induced better oppose in this case, the origin B. It better do that, right? Better do that. So how do I do that, right? Right. Okay. I'm using my right hand rule. And I think my eye should be, because the magnetic field should be like that. I'm so sorry, I already started wrongly. What am I talking about? Out means it's a dot. See, I'm already wrong, right? Even going slow, I'm wrong, right? So that's the origin B. So if you use E, better make an I which opposes this B, so it will be going in, and then my I will be like this, and it will be clockwise. I think my answer is clockwise, not counterclockwise. I'm not doing this to frustrate you, Daniel. I think the answer is clockwise. Aditya, I lost your video, yeah?
No?
Now, how did you, I lost your video just now. Now, Daniel, I can describe how I come into clockwise, but you also describe how you come into counterclockwise. How do you do it? How do I do it?
I use the right hand rule.
Okay, so the right hand rule has a thumb and a grip, right? So that's what I'm talking about. So where is your thumb pointing and where is your grip pointing?
Thumb is pointing out of the paper. field.
If you're doing that, then I agree that you will get some sort of counterclockwise. That I agree. But why would you point your thumb out of the plane? Why would you do that?
Because it says the field is directed out of the plane of the paper.
Yeah, I do it totally in reverse lah. The origin B is definitely out of the plane. Totally agree with that. Okay, so in some sense, the north is like that, right? That's why it means that the north is like that and the south is behind here. That's roughly what it means. Make sense? By that B, right? Now, the induced EMF, according to Lenz's law, better oppose this thing. Better oppose. That's what Lenz's law said. So north, the induced EMF better generate a current that causes a magnetic field like that. The opposite of the origin. So I point my thumb in instead and I get clockwise. That's how I do it. The current is induced, right? Is this correct first or not? Is the current induced or not induced?
It's induced.
Yeah. If it is induced, then it comes from the EMF, correct? Right? EMF induced will have an induced current. Now, Lenz's law say induced current better do something that opposes the one that originates it. So there you go. That's my basis of thought. That's my basis of thought. Divya, still missing your video? Yeah, still missing your video.
Yeah, my phone was too hot and it says that I can't unlock it for the next few minutes.
That happens. Are you still doing it? Do you have a problem?
Yeah, I'm doing question 8, almost done with it, actually.
Right. So let me just confirm. Part 1, what kind of rule?
That is quotient rule.
Very good. Okay, then you apply part 2 and hopefully you check your answer correct. Then we can move on. Now, Daniel, how is it? These two central principle, you're not good.
Yeah, not the best.
If you can at least accept how I explained, then maybe let's see whether it works again in the next question. Maybe that's how we can do it.
Okay.
So what is your next question? Is it question 20? What do you know? EMF. Okay. What do you think will the answer be?
A. Right.
Okay, let me just confirm. Unique rotation. That means it's an angle that changes. Good. Your answer is A, right? Okay, so to your surprise, probably A is totally the wrong answer. And again, you're not using the d flux dt. Your problem stays the same, 18, 19, 20. We just don't get it. Let me show you. I am going to repeat the exact same thing. Okay, so what was it just EMF induced, right? EMF induced will be equals to minus n d flux dt, right? D flux dt, right? Now this is an angle, right? It's an angle. So inside the flux, there is BA cosine theta. Some people say sine, some people say cosine, whatever. I'm putting it in, right? EMF induced minus n. The B is constant here. The A is also constant here because the coil rotating, the A never changes, but the theta will. Right? B cosine theta d theta. Right? The point is, this is going to be the angle graph. This is d angle dt. So the gradient of the graph at T1, the gradient is exactly 0. At T3, the gradient is exactly 0. That is where the magnitude is 0. T1 and T3 is not maximum, that's minimum. Because the gradient there is 0, based on the formula. Based on that, can you give a different answer?
So it's B.
Because at T2 and T4, the gradient is the steepest. How do I know? Just look at the graph, right? So from 0, it go ting, 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 ting until it's steepest here, right? It does go to steepest there, and then it will reduces in steepness again. So at T2 and T4, definitely the gradient is steepest. So I think B is correct, based on the formula and the graph.
Okay.
And maybe you're happy, 21 no longer have induced EMF. Okay? It's something else already.
Yeah, 21 is something I don't know how to do, because there's a lot of calculations apparently.
21, you mean? 21?
Yeah.
21. Maybe to your good news for you.
Power
it's
is IV, right? So you're trying to find this bit of power.
I'm just going to revise it, right? But to your, hopefully to your good news, this is not as difficult as it seems, right? But the one before this is definitely harder than what you think, definitely. But this one, 21, I think easier. Aditya, are you okay with question 8?
Yeah, almost done.
All right. Tell me
I
when
messed
you're
up a
done.
little bit and I had to do it again.
Understood. Okay, so Daniel, let's accept a few things first. The current is alternating, right? The voltage also alternating. So the voltage and the current is not exactly at a constant number all the time. Definitely not. Would that be okay? So therefore, we cheat and we go and find the value, the RMS, IRMS, which can represent the peak and the valley by being constant. Put it another way, I put some of the peak here and some of the peak there. Then I will have a flat thing. I like flat things. VRMS and IRMS is a flat thing. Would that be okay so far?
Mm-hmm.
This will be 70% roughly of the peak. That means the peak here. So V peak. Right? Roughly 70%. I'm using 70% as a guideline so that so we can accept it better. It's around 70%, not 50%, for example. Right? However, in a more accurate way, the VRMS will be V peak divided by root 2. This is again around 70% of V peak. Would that be okay?
Mm-hmm.
Right. So power peak will be equals to V peak and I peak. Which peak is not what we are interested in. We'll be interested in the average power. The average power will use VRMS, IRMS. Would that be okay so far?
Mm-hmm.
That means V peak root 2 times I peak root 2. Now guess what? That's half of V peak, I peak. That's half. So that's 50% of V peak, P peak. Again, the peak one doesn't matter much. The RMS is what is practically important. That's why we're interested. The peak is there for instant only. So to sum up what I'm saying, the VRMS, which is practical, is 70% of the V peak. Same thing with the IRMS, 70% of IP, which is represented as divided by root 2. That is what you should write. But to understanding, 70%. The P peak is not what we're interested in because it only happens at the peak. That's saying your maximum speed in canoeing is what matters. That's not true. What your average speed is what matters. Something like that, right? Your average power is what matters, not just the dash in between. Maybe the dash matters at the last part, but throughout the race, I would go for a better average power, so to speak, better average speed, something like that. So there you go. P average. P average, we'll use VRMS, RMS to cut things short. It will be 50% of the power peak, something like that, based on math. Will this be okay?
Yeah.
Right. Now, that's the basic stuff. No? So now let's understand the question. Now. This is a direct current. Does this VRMS, Vpeak thingy applies to a direct current?
No.
Very good, because direct current already flat, right? So direct current, what's the P peak? There is no peak. The P is just the P. What's the PRMS of direct current? There is no RMS. It's P already. It's already there. So happy lah for the first sentence. Suddenly I lost my list. Now he then say, I give you another alternating current. So basically, if I want to switch my current to alternating, because alternating is just easier to generate and give, would I need a higher I peak, or would I need just the same I? So for example, I am now an alternating current. I'm changing my DC I into an AC I. Can I just use the same value for the peak? Can I do that or not? Can I just choose C lah, basically, if I want to get the same power? What's your logic?
No.
Why is that so? I agree with you. Why is that so?
The vibes.
What do you mean by the vibes?
I don't think you can.
I'll try to explain it. Right. So the direct current already flat, correct? Already flat, but the alternating current is alternating, right? Alternating like that. If I touch the peak here, because I set my peak, you say peak, I set my peak exactly the same value as my flat DC. Obviously, I am not getting the same current every time. Only the peak one touches. Look at that. I'm so lagging. I'm so lacking in many other places. Correct? This is already obvious visually. Therefore, I won't be getting the proper average power. My lamp will definitely be dimmer if I just match the peak with my flat DC value. Does that make sense? If this doesn't make sense, please tell me. This is the whole thing. This is like the whole principle thingy.
Yeah, I guess so.
So let's say C is wrong. So the question, very simple one. Should my peak be higher than the original flat, or lower, or what? Where should it be?
Lower.
If my peak is lower, then am I in a better position or in a worse position to match my DC? I'm trying to match my DC here, right? Now I lower my peak. I want to match my DC. Is this doing it better?
No.
Obviously not. Don't lower the peak. I need my peak to be. I need my peak to be.
The biggest gradient.
I need, no, don't say the gradient. It is not the time to say gradient. There's no gradient. I need my peak to be higher, so that my average will be like equivalent to the flat load. Okay. This is mostly logic. Does that make some sense? Does that make some sense? It needs to make sense, you see.
Yeah, it does.
So never mind the math. The only possible answer is D, because D is only peak. The only peak which is higher than I. The rest is either the same or lower. That already does not make sense. Never mind the math for now.
Okay.
You don't get this from the slides, right? I mean, you don't get this understanding. I guarantee you, this is the understanding. This is what you need to understand. Everything will become easy if you understand this.
Yeah, I kind of get it.
So never mind the math, yeah? I haven't explained to you the math. Only the logic first. Logic first lah. Better lah. Okay. Whenever you're ready, question. Oh, time is up. 22, 23, 24, 25, 26. There's the parallel capacitor. Oh, and there's a very nice summary after that. Oh, that's very nice. Oh, okay, sure. Oh, they take it from the formula booklet. Can you give me a prediction when we see each other next Sunday, right? What would have happened at that point? At that point, what's our situation?
I can't say for sure.
Is there is there going to be something urgent, like, oh, suddenly there will be exam very close, or we would have done so many chapters in front, that kind of thing, will be lagging behind a lot? Will those kind of thing happen? Major stuff,
No, I don't think so.
All right, then please study by yourself first. I will see you on next Sunday, and we'll catch up at that point. Will that be comfortable?
Yeah.
All right, then. Good job for today. I will see you on next Sunday.
Okay. Thank you.
Bye.